Hello everyone. Today we are going to explore an important topic in deep learning, the vanishing gradient problem in recurrent neural network or RNNs. By the end of this session, you will understand why this problem occurs, how it affects RNN, and how architecture like LSTM and GRU help overcoming it. Let us start with the why. RNNs are designed to handle sequential data like text, speech, or time series signals, where the output depends on the previous input. However, the sequence becomes longer, training becomes unstable. The main reason for this instability is the vanishing gradient problem during backpropagation. Imagine this: an RNA is trying to predict the next word in the sentence. The cat sat on the mat. It works fine, but if the sentence becomes longer, like the cat after wandering through the garden for hours finally sat on the mat, the RNN forgets the earlier word cat. When predicting mat, this happens because the gradient information slowly fades away during training. Now let's understand what exactly the vanishing gradient problem is. During back propagation, RNNs multiply gradients repeatedly through many time steps. When the weights or activation derivatives are smaller than 1, these repeated multiplications make the gradient shrink exponentially. As a result, earlier layers or time steps receive almost zero updates. This leads to two key problems. The network forgets long-term dependencies and the training becomes extremely slow or completely stuck. In simple terms, the deeper or longer your RNN, the more your gradients fades away. So, where do RNNs and this problem commonly appears? They are used in many sequential learning tasks such as natural language processing, like chatbots, text translation, and sentimental analysis, speech recognition, converting audio into text, time series forecasting, predicting stock prices or weathers, music and text generation, where the sequence patterns are learned creatively. In all these areas, learning long-term relationship is vital, and that's why exactly where the vanishing gradient problem hurts performance. Now let's look at how this actually happens inside an RNN. Step 1. During the forward pass, the RNN process data step by step. Each hidden state depends on the previous one. Step 2. In the backward pass, we use backpropagation through the time, or BPTT, where the gradient flows backwards through all time steps. If we use active functions like sigmoid and tan, these derivatives are less than 1. Repeatedly multiplying these small numbers, making the gradient smaller and smaller. Eventually, it almost disappears. This is the Banyan gradient effect. As you can see, if each derivative is less than 1, the entire process goes towards 0. Let's talk about the challenges caused by vanishing gradients. RNN struggles to capture long-term dependencies. Training becomes slow and sometimes fails to coverage. Even the techniques like gradient clipping, the problem isn't completely solved. There is no also an opposite issue, the exporting gradient problem, where the gradient grows too large. Because of these problems or challenges, traditional RNNs often perform poorly on complex or long sequential tasks. Thankfully, improved architectures were developed. LSTM, long short-term memory, and GRU, gate recurrent unit. Both use gating mechanism that help preserve gradients and remember information over a long sequence. Let's wrap up with a quick summary. RNN face the vanishing gradient problem which weakens their long-term memory. The root cause is repeating multiplication of small derivatives during backpropagation. This leads to poor learning of long-term dependencies. Modern architectures like LSTM and GRE solve this issue by using gates that control and retain important information. In short, the vanishing gradient problem taught us the limits of traditional RNNs and inspired the innovation of more powerful models in deep learning. Thank you for watching, and I hope you now have a clear understanding of what the vanishing gradient problem is, how it affects RNNs, and why the architecture like LSTM and GRU are such game changers in deep learning.